Good morning, everyone. My name is Srinivasan and currently pursuing my degree in BTech of Artificial Intelligence and Data Science. Today, I'll be talking about my project title, Advanced Churn Analysis Using Deep Learning. This will be the agenda for our today's project. I'll be int- I'll be talking about the introduction, the statement of the problem, purpose of our project, methodology, which includes the architectural diagram, implementation, and important code segments, output and results, test cases, conclusions, and references. In today's hypercomputing business landscape, customer retention is more crucial than ever. Understanding and predicting customer churn, the phenomenon where customers stop doing business with a company, can be a game changer for businesses seeking to maintain a loyal customer base. Traditional churn analysis technique often falls short in capturing the complexity of customer behavior. However, with the advent of deep learning, particularly in the form of neural networks, we now have a powerful tool at our disposal to delve deep into the customer data and extract meaningful insights. In this presentation, we delve into the realm of advanced churn analysis using deep learning. We explore how deep learning models, with their ability to automatically learn representations from data, can uncover intricate patterns in customer behavior that traditional models might miss. We will discuss these challenges of churn analysis, such as dealing with high dimensional and noisy data, and demonstrate how deep learning can address these challenges to provide more accurate and actionable insights. Throughout our project, we aim not only to showcase the potential of deep learning in the churn analysis, but also provide practical guidance on implementing these advanced techniques in real world scenarios. Now, this is a statement of the problem. For the customer churn, the loss of customers is a critical issue faced by the businesses across various industries. Traditional churn analysis method often rely on simplistic models that struggle to capture the complex and dynamic nature of customer behavior. These methods are limited in their ability to provide accurate prediction and actionable insights for reducing churn. Deep learning offers a promising approach to address these limitations by enabling the extraction of intricate patterns and representations from large and diverse datasets. However, applying deep learning to churn analysis process several challenges, including the need to effectively process and analyze high dimensional and noisy customer data, as well as requirement for interpretable and explainable models to guide decision making. In this project, we aim to tackle these challenges by developing an advanced churn analysis framework using deep learning techniques. Our goal is to leverage the power of deep learning to improve the accuracy and effectiveness of churn prediction models, ultimately helping the businesses reduce customer churn and increase customer retention rates. The purpose of this project is to demonstrate the effectiveness of deep learning in analyzing and predicting the customer churn. By leveraging advanced deep learning techniques, we aim to develop a robust churn analysis framework that can be accurately predict a customer churn and provide actionable insights to reduce churn rates. Specifically, we seek to implement state-of-the-art deep learning models such as neural networks to analyze high-dimensional and noisy customer data, and to explore the use of deep learning for future models and extraction and representation learning to uncover hidden patterns in customer behavior, and to develop the interpretable and explainable deep learning models to provide insights into the factors influencing churn. Evaluating the performance of our deep learning framework against traditional churn analysis method to demonstrate its superiority in terms of accuracy and effectiveness. Through this project, we hope to contribute to the advancements of churn analysis techniques to provide businesses with a powerful tool to improve customer retention strategies. Now, this is the proposed methodology of this product, which includes a requirements analysis, data collection and preparation, feature engineering, model selection and architecture, training and testing, and deployment and monitoring. Now, we will be talking about the first topic, which is the requirement analysis. We will be discussing we'll be defining the scope and objective of this churn analysis product and to identify the key stakeholders and their requirements in the analysis to determine the specific metrics and the key performance indicators for measuring this churn. We'll be identifying the churn prediction accuracy required by the business and the data sources available. Next will be the data collection and preparation, in which we will gather historical customer data, including demographic, transaction history, and interaction logs. We will also be cleaning the data by handling missing values, outliers, and inconsistency. And we will also perform exploratory data analysis to understand the characteristics of data and identify potential patterns. The next topic will be the feature engineering, in which we extract relevant features from the data that can help in predicting the churn, and to transform categorical features into numerical representation using techniques like one-hot encoding or embedding. And we will normalize the numerical values or features to ensure that they are on the similar scale, followed by the model selection and architecture, in which we will select the appropriate data learning models for churn analysis, such as recurrent neural networks or convolutional neural networks. We will also be designing the architecture of the selected model, including the number of layers, activation function, and regularization techniques. We will also consider using pre-trained models or transfer learning to leverage existing knowledge and to improve performance. The next will be the training and testing of the model. In this model, we will be splitting the data into training, validation, and test datasets. We will train the deep learning model on the training datasets and tune the hyperparameters using the validation set. We will also evaluate the model's performance using the test dataset and metrics such as accuracy, precision, recall, and F1 score, followed by the deployment and monitoring, in which we will deploy the trained model into a production environment for real-time churn prediction. We will also monitor the model's performance and retrain it periodically with new data to maintain its accuracy. We will also implement a feedback loop to incorporate the user feedback and improve the model over time. This methodology provides a structured approach to conducting churn analysis using the deep learning, from requirements analysis to deep deployment and modeling. Now I'll explain the expected results and implementation, in which we will expect the results such as improved churn prediction accuracy, in which the use of deep learning models is expected to significantly improve the accuracy of churn prediction compared to the traditional methods. The model will be able to capture complex patterns in customer behavior, leading to more precise prediction. And we'll also talk about enhanced feature extraction, in which the deep learning models will automatically learn relevant features from the data, reducing the need for manual feature engineering. This will result in more efficient and effective churn predicted models. The next will be the interpretable insights, in which the developed deep learning framework will provide interpretable insights into factors influencing churn. This will enable the businesses to understand why the customers churn and take proactive measures to retain them. Now, this is a churn prediction framework of our model, in which we will use the customer data provided by the company, and we'll also use the data exploration, which means techniques for cleaning and processing the data. Now we will be splitting the data into training and testing models. We'll be splitting the models to training and data sets, in which we will be training the models up to the sampling section, and then the testing data set will go, and then the training model will go through a process of elimination and no feature selection. After all these processes, we will be evaluating a model through an optimal Keras model, which in turn uses random forest as well. And the last result will be the practical evaluation and interpretation of results. This will be the hardware and the software section required for our model. Please take a look into it. Okay, the next thing will be the implementation of this model, in which we will be talking about the data representation and implementation of deep learning architecture and the set data deep learning model. In this data representation, we will be using the framed daily event logs from various companies as RODMs, each consisting of JSON objects separated by new lines. Each object contains an event key that is common to all events, indicating the type of event log. The properties key also exists in all JSON objects, but varies in value depending on the event type and company. To identify the user events, the passage identified as a distinct ID key in the properties value box, which is present only for the user triggered events. Registered users have numerical distinct ID, while general users have long alphanumeric IDs. The time key in the properties value object contains a numerical Unix timestamp and exists in all of JSON event objects. Other keys in the properties value specific objects that are specific to the company and the event type. This will be the example of a JSON event where we'll be defining the event type in the event variable, and for the properties we'll be defining a class which includes a distinct ID as a variable, and we will be typing an anonymous user ID, and we will also check whether they are anonymous or registered, and we will be also be using the time which is the Unix timestamp, and we can also add other variables as much as we want. The next we'll be talking about the deep learning architecture. For this, we'll be introducing a new Python library called Theano, which is praised for its ability to define, optimize, and evaluate complex mathematical impacts. And this library compiles functions into optimized Python code, making computation fast, and supports GPU acceleration using the NVIDIA CUDA API. This automatic differentiation simplifies the backpropagation algorithm. It uses tensor objects to represent input and operations, allowing easy expression of functions. We will also be implementing the deep learning tutorials for the University of Montreal using the Theano, including logistic regression and multi-layer perceptron to understand how to implement deep learning neural network mechanics effectively. Now, this is the deep learning architecture of a model where we'll be dumping the raw data we received from the sources, and we'll be loading the data into the model, and now it will get selected. It will be getting the selected data. It will also filter the null values and anonymous users to get all the timestamps. After getting the timestamps, it will be splitting all the intervals based on the timestamps, which we have this model filter on split 1 and 2, 2 and 2, 2 and 3. After all these processes, we will be going with the vectorized by period and output, which will be given in the output return as vector or array. The same will be used in this column as well. Now I'll be explaining the deep learning model. In this deep learning model, we'll be using the LSTM, which is short for long short-term memory. It is also a type of recurrent neural network designed for sequential data processing. Unlike a standard recurrent neural networks, LSTMs can maintain a long-term dependency and remember the information from earlier timestamps. They consist of LSTM cells with input, forget, and output gates that control the information flow. It is also to note that LSTM learns to update their internal state based on input and previous states, making them useful for tasks like sequence classification and time series forecasting. They are widely used in natural language processing, speech recognition, and time series analysis. This is the flowchart of the LSTM where the model that is pre-processed will be sent to the input tree layer, which is also called as the embedding layer, where we can see the encoder and decoder at work. encoder and decoder work simultaneously with the help of the attention layer. And after going through this layers, we will be getting the outer tree, which is the extraction layer, which the output model will be the results we'll be expecting data predictions. Now this is the working of the LSTMs in which this is the question of the word embedding layer and this is the answer of the word embedding layer. These two layers combined with each other such that the when a user types on a particular sentence, this model will predict what the user will be saying the next. It will also use as a connector using the answer embedding as well. And after going through these fully connected weights, going through the holographic layer and software layers, softmax layers, we will be getting the output in the form of predicted output. And this is the implemented system of LSTM where it will be using the memory of the previous block, output of the previous block, and the output. This is the output of the current block and memory of the current block. It will also uses the sigmoid functions and then hyperbolic tangent and uses bias here as well. Now the vector operations it uses goes to elemental wise multiplication and summation as well. Results. We used 3 months of data containing the 49,883 instances. This is just but an instance. The data for first few months was employed for training and validation with 80 to 20 split, resulting in this many samples for training and this many instances for validation. Now we can see the flow chart on how the gender is split between male and female for the churn distributions and also whether the this circle diagram also checks whether the company churn is high or low. This yes column represents the churn in which in which we have to in which the company has to make sure they have to reduce this section as much as possible. Now we'll be talking about the implications of this model. Implications include improved customer retention strategies by accurately predicting the churn and understanding of underlying reasons. Business can develop targeted retention strategies to retain valuable customers. This can lead to increased customer loyalty and revenue. It will also the next thing would be the cost savings in which the retaining existing customers is more cost effective than acquiring new ones. By reducing churn rates, businesses can save on marketing acquisition costs, ultimately improving their bottom line. Competitive advantage, businesses that effectively uses advanced churn analysis techniques will have a competitive advantage in their industry. They will be able to anticipate customer needs and preferences, leading to a better customer satisfaction and loyalty. The next topic would be the intervention in customer retention management. This project will pave the way for innovation in customer relationship management practices. Businesses will be able to personalize their interactions with customers based on their churn likelihood, leading to a more meaningful and proper profitable relationships. This will be the summary of the literature review and the outcome of the in the conclusion. This project advanced churn analysis using deep learning demonstrates the effectiveness of LSTM models in predicting customer churn in the telecom industry. We'll be by analyzing the sequential data like call logs. LSTM models provide valuable insights for businesses to proactively address customer attrition and improve retention strategies. This project highlights the potential of deep learning in revolution. This will be the references. You can take a look at it you can take a look at it for more references. Thank you for listening to this project.